Hi. So today we are going to start a new series for theory of computer science. So the book we will use for this theory of computer science will be the by author KLP Mishra and Chandrasekharan. Hmm, I think the spelling is same or maybe one or more letters are different, but the book's author is this one. Okay, so let us see theory of computer science. So, formal languages are used in theory of computer science to examine the characteristics of algorithms and automata as well as to simulate many types of computing. For this, we need formal languages. In theoretical computer science or theory of computer science, formal languages are generally used, and the examples of it are regular languages, context-free languages, and Turing machine languages. We'll see all of these later on in the next videos, coming videos. So let us start with regular languages. What is this regular languages? So we have just seen that in theoretical computer science, we need formal languages. And regular languages are formal languages that regular expression can describe and can also be recognized by finite automata. What is this finite automata? We'll just now see. For the right now, you understand that it is a machine. They are used to define sets of strings such as sequences of characters or words that follow specific patterns. Okay, that follow specific patterns, like suppose some characters are how they are coming, how it will be accepted by some machine or not. So we'll see this regular languages are formal languages that need regular expressions which can describe and can also be recognized by finite automata. They are used to define sets of strings such as sequences of characters or words that follow some specific patterns. Okay, so you focus on this that it follow a specific pattern. Okay, we'll see like suppose A B oh, A B. So we have to define these strings that what pattern it is following. This is defined by the regular expressions. So see the formal definition of this regular language. A regular language can be defined as a collection of strings that are recognized by finite automata. So in regular language, we define that what are the different strings that is recognized by a finite automata, that is a regular language, and it is defined using these five tuples. An FA, this is finite automata, is a five tuple Q, sigma, del, Q naught, and F, where Q stands for finite number of states, sigma stands for finite alphabet representing the input symbols, del stands for the transition function. Okay, del stands for the transition function. Like, what does it mean? That some state is there. Okay, suppose this is a state and this is some state, and I'm saying that on A from Q0 it will go to Q1. So the del means it will say that from Q0 on A it will reach to Q1. This is the transition function, and this sigma is the alphabets. Sigma is the alphabets. We have just seen that sigma is the stand for finite alphabet representing the input symbols. Q stands for the finite number of states, means it will contain all the states we have in our machine or in our finite automata. Now see, there is a transition function and Q naught stands for the initial state. Q naught stand for the initial state. So generally in every finite automata you will see that the initial state is represented by Q naught, and one more thing, when we represent in the terms of this diagram we use this arrow symbol to show that this is your initial state. After that F is a final set of final states. Okay, F is also a subset of Q. F is also a subset of Q because it is also a state. So it is a subset of Q, and your F yani means the it can be the set of final states. Means it is not necessary that only one state will be final state. You can have multiple states as final states. Like suppose here from Q naught to Q1, this is final state, and this may be also the final state. Okay. So here on some symbol, like suppose for example, it is that this is going to Q2, this is also a final state. So here we will say that Q1 and Q2 both are final state. So this finite automatas and regular expressions specify patterns or rules that define a language, such as a sequence of characters that must or must not appear in the string. Means we specify that this sequence of characters should be there, this should not be there. The words in a regular language must follow the rules specified by the finite automata or regular expression to be the part of the language. What does it mean? The finite automata, which is this regular expression, is saying that strings will be the part of that language. Okay, and other strings will not be accepted by that automata. So see, suppose if I say, for example, that set of strings that contain exactly two b's, and the language has this input symbol a or b. Suppose it has the language input symbol a or b. Okay. Okay. Okay, see, suppose your input symbol is A and B. Here, this is input symbol is A and B. So we can make strings of A and B. But the restriction here is that it should contain exactly two B's. Means B should be only two and A can be any number of A. It can be no A. Like suppose if a string is BB only, this is also accepted by this. Or if I write A B B or B A B or B B A, all these are containing one A. Here there is no A. Here it is one A. Now A can be two, but it is not specified that where A will be. So it can be both A at same place, or but B should be exactly 2B. So B can be anywhere, like suppose AB or AA BB, and there can be many A's after this BB and so on. We can have this. Just thing is that you have to see that there should be not more than two B's and not less than two B's. It should have exactly two B's. Next example is set of all strings that containing substring 1 1. Suppose in this language the input alphabet suppose is 0 and 1. Okay, so now the strings that can be formed using 0 1 can be many, but here it is the saying that it should contain the substring 1 1. So it can be this string also. Okay, only 1 1. It because it 1 1 can be the subset of itself. Next, and this 1 1 is a substring, means it will be kept us together. It can have 0, 1, 1. It can have 1, 1, 1. Oh, okay. So substring is 1, 1 is there. Here also 1, 1 is there. It can be 1, 1, 0 or 1, 1, 1. Both are same. So we do no need to write here. Okay, but you should understand that this 1, 1 should be together. Or you may be asked that 1, 0 should be together. It should have 1, 0 as a substring. So you have to think about the all the strings which can contain this substring in that language will be the acceptable by this language. Okay. So we'll see more about this regular languages properties in the next video. Thank you. Thanks for watching.